Hi everyone, welcome to another video of my YouTube channel Data Science with Sam. You must be wondering that why I took a 1 month long gap to release another video on my YouTube channel. Well, I was a little busy with my academic project related to deep learning. In one of my forthcoming videos, I'll definitely give you a brief overview of the academic project that I worked on in the last 1 month. But let's take a look back what we covered in our last video. As you know that I started a series of predictive model validation covering some intriguing aspect of how you can validate the accuracy of your models, because it's very important to validate the accuracy before you productionize your model or use it for future reference. So in my previous video, I covered there are 3 different metrics that we use to validate accuracy of linear regression model. One is R-square, another one is RMSE, and the third one is MSE. So let's take a look at that video first before we go into the next section, okay? In today's video, I'll cover how we can validate the accuracy of logistic regression model. Because as linear regression, it's also very important to validate the accuracy when you are dealing with output classes, which they are binary or multi-class. Because for logistic regression, we usually get output in as a binary like 1 or 2, or sometimes it's multi-class based on what you are predicting. So let's go to the next section to find out what kind of evaluation metrics we're going to use to validate accuracy or evaluate our logistic regression model. There are 2 widely popular model evaluation metrics we used to evaluate the accuracy of our logistic regression model. One is confusion matrix and another one is ROC-AOC curve. For today's video, I'll cover only the confusion matrix part. So confusion matrix is nothing but a table that represents the performance of logistic regression model. Each row represents the actual class or the real world value of the table, and each column represents the predicted class coming out of your model. Sometimes this term considered very confusing, that's why we call it confusion matrix. But let's dive into the 4 basic terms of confusion matrix. For example, we have a sample of 12 COVID-19 patients. And out of 12 patients, only 8 were diagnosed with COVID, and the remaining were diagnosed with no COVID. So in that case, the actual class of the COVID patient will be 8 positive and 4 negative. But when you try to evaluate the model, you evaluate the COVID-19 cases from your model, the matrix could be different. So there are 4 terms we use to define that. So first is true positive. So what is true positive? There are the cases where our model predicted yes, and also in reality, those patients do have disease. So that means model are able to predict the COVID-19 accurately. So we call those cases as true positive measure. What is true negative? Suppose your model predicted no, and also in reality, if those patients do not have disease, so that particular measure will be considered as true negative. What is false positive? False positive is, suppose your model predicted yes, but they don't actually have the disease. So in that case, we consider it as a false positive measure. We also call it sometimes type 1 error. Then next is false negative. Suppose your model predicted no, means the patient does not have COVID-19. But suppose in reality, they actually have the disease. So in that case, the measure would be considered as false negative. We also call it false negative as type 2 error. So if you combine this true positive, true negative, false positive, and false negative into the confusion matrix, you'll be able to calculate some different measures, which I'll discuss in the next section. In previous section, we talked about the 4 basic terms of confusion matrix of a binary classification model. True positive, true negative, false positive, false negative. Now let's dive into that, how we can calculate the accuracy or other prediction matrix using those 4 terms. So let's first check out the accuracy score. That means it's going to tell you that how often that binary classification model proven as correct. So that's the formula, true positive plus true negative divided by the total number of patients will give you the accuracy score. The next measure is true positive rate. So suppose your predictive model sometimes predict yes, and how many times it will come as accurate prediction. So in that case, what you'll do, you'll basically divide true positive with the actual yes classifier. Sometimes this measure called as sensitivity. The next one is false positive rate. So if suppose in the actual scenario, if the patient don't have COVID-19, but your model predicted yes. So what's the accuracy, the misclassification rate of that? So in that case, you divide your false positive by the actual yes, actual no, sorry. Then what is true negative? True negative rate is nothing but a specificity. Here it's showing that if the actual class is no, so how often your model will be able to predict that that patient does not have COVID. So you usually just divide true negative by the actual no. It's also considered as a specificity measure. The next one is precision. So suppose sometime your model predicted yes. So how often that prediction is correct? So in that case, you basically divide true positive by the prediction yes, and you get the precision. In order to get the recall, you actually have to define that how often the prediction is yes, but it's also yes in the main sample. So in that case, you need to divide the actual yes by the total number of patients. So that's how you get accuracy, true positive rate or sensitivity, false positive rate, true negative rate or specificity, precision, and recall. So in previous section, I showed you how you can use 4 basic terms of confusion matrix to calculate the accuracy score, precision, recall, sensitivity, or specificity evaluation matrix. That will be very useful for validate the accuracy of any logistic regression model. If you want to understand how you can calculate accuracy of a multi-class classification model, you may have to redefine your confusion matrix. For example, for my binary classification model, I used 2 columns, 2 rows, because we have only 2 classes, COVID or non-COVID. But if you interject 1 more classes to that, so you have to increase the rows and column. So the number of rows and number of columns will always be similar to the number of classes you're going to use for your logistic regression model. So that's all for now. Please follow my YouTube channel and don't forget to like and subscribe to my videos as more data science related contents are forthcoming. Also, I would like you to take a look at the video caption as I'm sharing some learning materials that will give you more overview about this particular predictive modeling evaluation techniques. So in my next video, I'll talk about the ROC-AUC curve, the other evaluation metric that you can use to validate your logistic regression model. So till then, goodbye, stay safe.